Hello everybody, we're back for SAT Math Level 1, Strategy 18 and 19 today, and this is the email address that you need to contact for more PowerPoints, videos, and solution PowerPoints, and tutoring. If you need tutoring, email me here, and I can set up a online tutoring schedule for you. Lesson 2.1, Math Strategies You Need to Know. Math Strategies 18 through 19, 36 points of note-taking here, students. So you should be taking notes during these PowerPoints. If I go too fast, go back and relook at the video again and pause it to take notes. There's valuable notes to be had in these videos. Or order a PowerPoint so you can go through it at your own speed, on your own time, in your own computer, in your own phone, whatever. Example, no calc section, multiple choice. F of x is divisible by x minus 5. 2, in the interval of this interval here, exactly one x value satisfies the equation f of x equals 5. And then 3, multiple choice here, x plus 2 quantity is a factor of f of x. The diagram here, excuse me, shows a graph of a polynomial function f. Which statement or statements in the box above must be true? So looking at this graph here, and then considering these three statements up here, which one of those must be true? 2 only, 3 only, 1 and 2 only, and then 2 and 3 only. Which one of those are true? Okay, page 2, here is our graph again that we're trying to solve. The SAT assumes you know some basic facts related to polynomial functions and their graphs. If the graph of poly function intersects the x-axis at a point whose x-coordinate is c, for example, down here, here, or here, then the following statements are equivalent and interchangeable. F of c equals 0. C satisfies the equation f of x equals 0. And then x minus c is a factor of f of x here. F of x is divisible by x minus c. So all these factors, all these statements here could pertain to this graph. Okay, continuing on here with this problem. Here are our choices again, 1, 2, and 3. Consider each of the choices in turn now. Since the graph does not intersect the x-axis at x equals 5, f of x is not divisible by 5. Statement 1 here would be false. We can strike that. This x minus 5 would be where it would be like here. In the interval between here, 0 and 6, the line y equals 5 intersects the graph at only one point, so there's exactly one value of x that satisfies the equation f of x equals 5, since statement 2 is true. So statement 2 would be true in that case. Since the graph crosses the x-axis at x equals -2 over here, x minus a minus 2 or x plus 2 is a factor of f of x. Statement 3 is true. So it would be 2 and 3 only of those statements are true. So that would be a way that you would reason through the possibilities for this. Example, no calc section. We have this function here. In a polynomial function p of x, c is constant, if p of x is divisible by x, what is the value of c in this case? Here's our possibilities. So a polynomial function has a general form of like this here, where you have decreasing order of your exponents, and so the degree is in a decreasing order, and then you end with a constant over here. If p of x is divisible by x, then the value of the constant term k must be 0. It will be a remainder. So having these as a possibility here, p of x is in standard form, removing the parentheses and collecting like terms, we come up with something like this. And then we combine like terms, 48 plus c here, because we know c is our constant. 38x here. Let's see, 44x and minus 6x. So that would have to equal 0. Factor for it. Set the constant term equal to 0. So that 6c would have to be negative 48, so c would have to be negative 8. Looks like right here. Okay, so we have page 7 here on this section here, example, a calc section here, grid in. In a figure, what is the value of cosine x minus sine x here? So these two angles here are equivalent. Since the base angles are equal, the triangle is isosceles, so dropping a perpendicular from the vertex to the opposite side bisects the base and creates two smaller triangles with side lengths that form an 8, 15, 17 Pythagorean triple here. So sine x equals side opposite angle x over the hypotenuse is 8 to 17. Then cosine x is 15 over 17. So cosine x minus sine x would equal 7 over 17 here. 15 17ths minus 8 over 17. So you grid in 7 fraction bar, 7 fraction bar, 17. So it's 1 and then 7. That'd be your grid. Page 9 of the exercise here. No calc section in xy plane, 0 is the center of the circle right here. And the measure of angle AOB is k pi radians. What is the value for k? So since negative 1 square root 3 equals xy, y over x equals negative square root 3 over 1, so triangle AOC is a 30-60 right, where the measure of AOC equals 60 degrees. So here we go. Sorry, AOC here is a 60 degree. AOC, we have a 60 degree angle here. Hence, AOB measures 120 degrees. AOB, this is 120 degrees. Measures 120 or equivalently 2/3 pi radians. So grid in 2/3 here for that. So it'll be 2 fraction bar and then 3. Page 10 of our lesson, strategy 19. Know how to find areas indirectly. In order to find the area of a particular region, it may be necessary to find it indirectly by finding different. Okay, here we go now with page 11 of this lesson here. Example, no calc section, multiple choice. The figure shows a quarter circle with center 0. If the length of diagonal DM, which is right here, of rectangle ODCM is 8, so the diagonal is 8, and M is the midpoint of line OB. M is the midpoint here of OB. what is the area? What is the area of the shaded region here, which is this part here? And then here are some possibilities here to describe area. The area of the shaded region is the difference between the areas of the quarter circle and the right triangle DOM. So we have an area here and then another area here. The only thing that we don't have from this quarter circle is this triangle here. So since the diagonals of a rectangle have the same length, OC equals DM, OC equals DM. OC is the radius of the quarter circle. Here is the radius. Hence, the area of the quarter circle is 1/4 pi times 8 squared, which equals 16 pi. Since segment OB is also a radius, OB equals 8, is given that M is the midpoint of OB. M is the midpoint of OB, which is over here. OM equals MB, OM equals MB. In a right triangle DOM, use the Pythagorean theorem to find the length of OD to find this length here. So we're going to find this length here. OD squared plus 4 squared equals 8 squared. We do our algebra here. OD equals square root of 48. And that equals that. 16, square root of 16 times square root of 3, 4 times square root of 3. So the area for the right triangle equals 1/2 times blah, blah, blah equals 8 square root of 3. And then we subtract that, don't we, from the area of that quarter circle. 16 pi minus that, and then we get 8 times 2 pi minus square root of 3, which is C. Page 15 of our worksheet here. Example note calc section, grid in. What is the number of square units in the area of the quadrilateral shown here? So what is the area here? Draw line segments to form right triangles at the upper and lower corners of the quadrilateral. Here is 2 triangles here. Find the area of the quadrilateral indirectly by subtracting the sum of areas of the 2 right triangles from the area of the square. So area of a quadrilateral equals area of a square ABCD minus right triangle 1 and right triangle 2. So 5 times 5 minus here is right triangle 1 and right triangle 2. 25 minus 8 here equals 17. 17 for that one. Then we're on page 17. Figure shows the logo in the shape of overlapping equilateral triangles ABC and DEF. If AD equals DC equals CF equals 4. What is the area of the shaded region? And then here are possibilities here for that. So AC equals DF equals 4 plus 4 equals 8. AC equals DF, which is over here. Since the measure of EDF equals this equals 60, triangle DGC is equilateral with DC equals 4. DC equals 4. The area of the shaded region is the difference between the sum of the area of the 2 overlapping equilateral triangles and equilateral DGC. To find the area of the overlapping equilateral triangles, use the formula area equals side squared over 4 times square root of 3. Area of the shaded region is area ABC, DEF minus area DGC. Then here we have that here. We plug in our values there. When we get this is 28 times square root of 3 is what this comes out to. And there it is for B. Okay, so if you want this PowerPoint, you want further PowerPoints and videos, do you want supporting PowerPoints and videos for areas of math that you have a deficit in, contact me here, animatedpowerpointmathvideo@aol.com. Thank you very much.